Hi, my name is Jonathan and I'm the project coordinator.
Hi, my name is Nguyen. I'm going to do file I/O and interface.
Hi, my name is Andrew Shinjo and I did the hash tables.
Hi, my name is Dan Nguyen. I do the friend recommendation with graph data structure.
Hi, my name is Tam Huynh. I did a BST, and then our group is going to present about the singers from the 2000s.
In this presentation, we will provide an overview of the project, UML diagrams representing how our data structure interact with each other, results from our walkthrough, and a live demo to demonstrate our program. The program will allow users to create their own profile and to interact with other users. Users can add other people into their friends, remove people from their friend list, and look for users by searching via name or by interest. The program will also offer friend recommendations based on factors that will be discussed later in the presentation. Our data sets for each user contain a username, first name, last name, city, list of hobbies or interests, and a binary search tree of a user friends. The password for each user is private and is contained in a separate class and text file. There is a class register each user with their password for the guide. All of the data of each the singers from the 2000 was found online. However, our hobby list includes some extra hobbies that are random animals, just so the graph could later on find the distance and friend recommendation easier. Since the user depends on the login system, so every time the program runs, the login system will appear first, and then it's going to check the username and password. If the username and password the user type correctly, it will pass the data to the user. And if it's not correctly, it will require user to type the username and password again. I suppose the user type username and password correctly, then the user will get the data from that user, and it passes data to the search new friends, to the view my friends, fan recommendation, fan profile, and my profile. After it passes the data successfully, the main menu will appear. It allows users to use our program. That's it.
To create hash tables that allow us to search by interest, we created two functions, an insert function, another insert function, and a get data function at a specific key. We use the interest as a key in our hash table to allow us to easily search via interest. For example, if the main user types swimming into the program when checking for similar interests, swimming will be the key in the hash table, and it'll return a list of people who have the same interest swimming. The get data function, which is our third addition, helps assist with the friend recommendation class. For the friend recommendation class, we have a user ID hash table for each user, and it contains the ID of all users that share the same interest. We use getSize as the limit of a for loop where we check if each user ID in the hash table is friends already with the main user. If they are friends, we do not show them in the friend recommendation, but if they are not friends, we do show them in the friend recommendation.
Okay, hello, so my name is Dan. I am responsible for the friend recommendation functionalities of the social media. So for the friend recommendation by both distance and interest, I use the graph data structure and the list data structure to accomplish the function. So the graph is almost the same with the lab, but I add one more function. I add one more private variable, which is the rank. It is the vector of the list of integer, and I change from array list to all vector as you recommend. So this vector of list of integer will store all the ranks of all the people based on the distance to the original source. The source is the person who is looking for friend recommendation. The people who are close to the source, who they will have the distance of 1, and of course the source have the distance of 1 of 0 to the source, and so the people who are close to the source will be added first, and then the people who have the distance of 2 and 3 and possibly 4 and 5 will be added later, based on the distance of to the source. And then I add one more private method, which is a rank. This rank is a private helper to the rank string method that brings the list of the people based on their distance to the original source. Then I sort the list of the people with the same distance. Only the list of the people with the same distance, by using the number of similar interests that this person have with the original source. So in that way, I can sort people based on both distance and interest to the person who is looking for friend recommendation. So to do this, where's the list method? So to do this, can you click on the list? So to do this, I add one more method to the list, data structure called add before iterator, which is similar to the add iterator, but it adds the element before the iterator. So okay.
So for the BST class, I just basically, like, instead of the generic type, the BST would take user. And then I actually didn't add any more functions. The BST is supposed to maintain the user's friend list, so it use in order print to make the user's friend's name like in order of alphabet. And then I don't know.
Okay, so this is our walkthrough results. So, feedback from participants. When searching for new friends, names with capital letters are not included with the search key. So we fixed this pretty easily by making it case insensitive by just changing the search key to lowercase. New friends can only be searched by first name. So we just kept that as is because that's just how a hash table works. We don't. Our search only searches by first name. We can't search by first name and last name because that would require another hash table. For friend recommendations, we only show just the friends. We don't show how many mutual friends or any data about that friend because it would take up too much space in the program, and it'd be kind of cluttered to see all that information. So friend recommendation list shows friends who are already in the user's friends list. So we fixed this pretty easily, and it's fixed in our code.
This is a live demo. We're gonna run login system. I'm going to type the username with the wrong password. Let's see what happened. It will complain me the user or password incorrectly, so that's why I have to retype again. Now login successfully. That means I use correct username and password, and I'm going to check my view profile from PNC. this is her first name. I mean, this is her full name, and then the city, and this is her hobby or interest. Then I'm going to check the another account to make sure that's it. They are different. Let's check the user Tay. This user Tay, and then Taylor 1999. I'm going to log in, and I log in successfully. View my profile, and I have a different name and different city and different hobby. So that means every time I log in a different user, the program will display a different profile of that user.
So now we're gonna go to view my friends function. This is Beyonce's friend list, and we can view her friend's profile for Alicia Keys. This is her profile. Then for another friend, and then we can remove them from the friend list, like now, and then check it again. So we see that Alicia was removed from the text file, and then we're gonna test the edge case where like all of her friends were all removed. She got so many friends. Okay, so the friend list is already empty, and then the text file is empty.
Okay, I will now show how to search by interest, which uses our hash table. So currently our friend list is empty for our user, and I will go to the search new friend function. First, I will search for a interest that does not exist among any of our users, and our interests are right here. So I search, and it says that QQQ is not available, and I will try to add a friend here, and our program successfully blocks it because this should not be allowed. Now I'll try to search for an interest that does exist among our users. One of them is worm, so I will search for it now. And 5 of our users have worm as an interest, and this is consistent with our text file. And I will try to add one of them into my friend list. And I'll go back, and yes. And you could see that in the text file the friend list is successfully updated. And I'll go to the view my friends in the program, and Christina is in our friend list. Then I'll go back to search new friend, and I'll try to add her again and show that our program does not allow us to add a person who's already in our friend list. And it says Christina is already in your friend list, so it does not allow us to add her again.
Okay, so now we're gonna search by friends by their name. So we're gonna do search by name, and we're gonna search for a user. I'll search for Taylor, and this is a result. We could view her profile. These are her names and interests, and these match up right over here. And we can add her as a friend, and press back. And now our text file is updated, and Taylor is now in her friends list, and it's right here. Now we can search by a name that does not exist. We can search by someone named Andrew. We can search, and then it shows Andrew is not available. We can't view his profile. It shows name and city and interest is all no. And when we try adding him as a friend, we cannot add the user because that user is not in the community of users. And we could go back, and we could search for another user. Search for Katie, and we could search her name by uppercase letters or a mix of either. Search, and we see it's Katy Perry. View profile. You can add her as a friend, and go back. And we could view my friends, and there's Katy Perry right there.
Okay, so I'm going to demonstrate the friend recommendation functionality. So I'm going to log into Christina to see her friend recommendations. So these are the friend recommendation by the order of the distance from Christina and the number of shared interests with Christina. So as you can see here, but these people are not the people who are already the friend of Christina, which are Demi Lovato and Dwayne Carter, will not be listed in friend recommendation. These are the people who are not friend with Christina. So the distance with Christina from these people to Christina are 2, and the distance of these people from Christina are 1, because these people are the direct friend of Christina. So these people are distant from 2 from Christina. Kelly Collection, he shared, as you can see here, Kelly Collection is here and Christina is here. These 2 people share 3 similar interests. We count they share 3 similar interests. And Katy Perry shared also 3 similar interests with Christina. But Kanye West only shared 2 similar interests with Christina. That's why Kanye is below Kelly Clarkson and Katy Perry, who share 3 similar interests. And then maybe this guy will share like 1 or 0, and then the people with the distance of 3 will be listed down here, and the people with a distance of 2 will be listed up here. So the friend recommendation will list by distance first, and then apply the number of shared interests to the people with the same distance. And then if we move down 1 distance, it will move like to the number, like to 3 distance, to 4 distance, to 5 distance, and just like that. Stop. Okay. So when we add Katy Perry and back, and of course Katy Perry will be shown here, and then not here. Thank you.